A silicon wafer is thinner than a sheet of paper and cracks if it bends even slightly. To move it, polish it, or inspect it, something has to hold it perfectly flat. Without clamps, without scratches, without a single trapped particle. The gray disk turning here does it with nothing but air, drawn evenly through millions of microscopic pores. The secret is the surface itself. Instead of a few drilled holes that grip in spots, an open network of fine pores. Roughly 30 to 40% of the body, with openings as fine as 15 micrometries, spreads the vacuum evenly across the entire face. A wafer feels one gentle, continuous hold rather than a pattern of pressure points, so it stays flat and unstressed. What touches the wafer has to be harder than anything it might drag across it. High-purity alumina reaches a Vickers hardness around 1800, so the working face resists scratching and wear through countless cycles. Lapped flat and parallel, it gives the substrate a stable, repeatable plane. The foundation for accurate alignment, dicking, and inspection. 2 more traits matter in a cleanroom. Alumina is an excellent electrical insulator, so it adds no stray charge that could pull dust onto a sensitive wafer. And it stays chemically calm against the acids, solvents, and cleaning agents that flow through these lines, shedding almost no particles of its own. The hold stays clean as well as steady. Those abilities come straight from the chemistry. Aluminum and oxygen bond into a dense corundum lattice held by strong ionic and covalent links. That tightly packed structure is what makes alumina so hard and so stable, and because its electrons stay locked in place, almost no current can pass. The same bonds give both the wear resistance and the insulation. Purity decides how well it performs. The higher the alumina content, the cleaner the grain boundaries and the more uniform the surface, which keeps contamination low and suction predictable. The pores are not flaws but a designed network, sintered into the body to carry airflow without weakening the face. No two machines hold a substrate the same way, so each chuck is built to the drawing. Round faces cover wafer formats from 2 inches up to 12, square and oval plates reach past 500 millimeters on a side, and thickness runs from a few millimeters to around 20. The porous zone, the sealing rim, and the mounting all follow the equipment. Inside that outline, the details are tuned to the job. The pore size and porosity set the suction strength, the vacuum channels balance airflow across the face. Mounting holes and a sealing edge match the fixture, and the surface is lapped to the flatness the process demands. The dense base can be ceramic or metal, chosen for rigidity and cost. Nowhere is a steady, gentle hold more critical than in wafer processing. During back grinding and dicking, a wafer thinned to a fraction of a millimeter must stay dead flat while a blade or wheel works across it. Any flex or vibration becomes a crack or a lost die. Drawn down evenly across the porous face, the wafer is held still without clamps, its whole underside supported at once. The hard alumina surface resists the abrasive slurry and grit without scratching back, while its insulating, low-particle nature keeps the wafer clean and free of stray charge. Remarkably, the part doing the most exacting work on the line is the one that never grips the wafer at all. It simply holds it on a cushion of vacuum and lets the cut run true.